Hello, ladies and gentlemen. We're going to talk about vectors today. So, difference between vectors and scalars. Scalars are ordinary numbers, like you're used to, mass, time, and so forth. Vectors have both magnitude and direction, such as force, such as velocity, and so forth. Distance, the displacement, the position of something is a vector quantity. We either bold or put an arrow over it or do both. In the old days with typewriters, people would put underlines. Multiplying and dividing vectors by scalars. Scalars are ordinary numbers like 2, -1, -1/2, and so forth. It only changes the magnitude, not direction. When we draw a vector, we draw an arrow that's proportional to the length. So A is this long, 2A is twice as long, -A is A flipped around, half A is half as long flipped around. Opposite direction. Negative will just make it the opposite direction. Vector addition. So there's two ways you can think about it. You can put the two vectors together and draw the diagonal from the tail of both to the opposite side of a parallelogram. So that gives you your sum. You can also think of it as tip to tail. So you have the tail of A and the tip of A, and then the tip of A goes to the tail of B, and your resultant vector is from the tail of A to the tip of B finally. You'll notice it doesn't matter, the order doesn't matter. You get the same result either way. And the same thing with the parallelogram rule. So order doesn't matter, and you can group any way you want to also. And so you group B and C, you get a result, you add it to A, or add A to B and then add it to C. It doesn't matter. The rules of algebra, just like we're used to so far, just like we're used to. Subtraction. The best way to think about subtraction is you're adding the negative vector. So here's B, here's negative B, and here's the parallelogram, and here's the tip to tail. A, negative B, and then the result. So here's an example. We have this vector. You could do it, well, here's the trigonometry fashion using trig, and this applies the cosine law. This applies the sine law. Most people don't do it this way. I'm going to show this example once, and I probably will never use it again. Because what you do is you say, okay, the resultant, that's the, it's kind of like the Pythagoras theorem. You take the side of this side squared, you add this side squared, and then you subtract 2 times the length of this side times the length of this side times the angle, cosine of the angle between them. And that will give you FR. Okay, or 213 newtons. The sine law then lets you get the angle theta here. So now that you've got FR, you can take, okay, FR over the sine of 115 has to equal the length of this side. Here's 100 newtons, or the length. Yeah, let's take the length of this side. See, oh, opposite. We got to go opposite. Sorry, theta. So here's 115. Sine law works opposite. The opposite side divided by the sine of the angle. Opposite side in this case is 150 newtons right there, divided by the sine of theta. So here's sine of theta, here's 150 newtons, and 150 divided by the sine of theta equals FR divided by the sine of 115. And you get theta equals 39.8 degrees. Phi, the angle from the x-axis, you have to add 15 degrees to that. So that'd be 54.8 degrees. Most people don't like that. Most people prefer this method. You break down vectors into components, into an x coordinate, an x amount in the x direction times I hat. I hat is the unit vector along the x-axis. J hat is the unit vector along the y-axis. So you can see that f, the f vector, is the sum of this vector. So we're separating out magnitude, which is fx, and direction, which is I hat, plus the magnitude in the y direction times the direction in j hat. I hat and j hat tell us the direction. Fx and Fy tell us the magnitude. So the resultant x, you just add components when you're adding vectors, and you break it down to all the components, and then the total amount in the x direction is f1x plus f2x plus f3x. Total amount in the y direction is f1y plus f2y plus f3y. And of course, f3y is negative, f2x is negative. And the angle of the resultant we can get from the arctangent of the resultant x-coordinate divided by the resultant y-coordinate. Actually, that'd be the arc cotangent. Arctangent would be distance up divided by distance adjacent. Okay. Here's an example. So cables, the force of in a cable in a rope is directed along the cable, by the way. That's kind of a neat rule. So we want to know the components of F in two different ways. Force, in 900 newtons is the total force using this coordinate system. Well, we have 40, 80 this direction, so we can find alpha, arctangent of 40 divided by 80, and we know the total quantity here, so we can get the force by taking 900 times the sine of alpha will give us f sub x. Most of the time people find the angle between the x-axis and they'll find the x-axis, the angle between the force and the x-axis rather than the angle between the y-axis. Watch out for that. In this case, they're doing the y-axis. So force is going to equal the magnitude, 900 newtons. Notice the notation. They'll put the unit in parentheses at the end of the equation. 900 newtons sine of alpha, that's this length, plus 900 newtons times cosine of alpha, and in this case it's negative. And we can get, we can also use the Pythagorean theorem. So we can set up a similar triangle. This length right here is 89.4 meters, and now we have similar triangles. 900 is to 89.4 as fx is to 40. Yeah, 40 meters to 89.4, 80 meters to 89.4, and calculate it out. Okay, 3 dimensions. And we are getting, the video is getting a little long, so we're going to make a second video picking up with 3 dimensions. That's the next video.